So hello everyone, welcome to this another video of Scale Up India. In this video we are going to discuss about collection framework or the popularly known as collections in Java. Now before we go for collections, let's discuss why do we need a collection framework when we already have arrays with us. So let's see what are the problems with array. Now the first problem with the arrays is that these arrays are fixed in size. Now you may say that okay, we can create an array of size 10 also, we can create an array of size 100 also. Then why the arrays are fixed? I'm saying so because once you initialize an array, let's say of size 100 here. Now in future, if you wish to add 200 elements, that is not possible. If you wish to just add 50 elements, then also it is not possible. I mean, rest of the 50 spaces will be just wasted here. So that is a major problem with the arrays. And in the real world, as you know, so let's say if you have a company and you are using arrays to store all the customers. So what will be the size will you keep? Will you say I will be having 100 customers in future or 200? Maybe your company is very popular. You have millions of customers. So that will be very difficult. And if you will say that initially only we will create an array of millions, then let's say your company doesn't works well, or in our case like we have only very few subscribers here. So what will I do with an array of size million here? All the space will be wasted. So that is one of the major problems with the arrays. Another problem is that the arrays are not implemented with the help of any specific data structure. Because of this reason, we don't have some ready-made methods for most of the common problems. So one of the common issues which we do with the data is we need to sort the data. So let's say here I'm having an array, integer array of size 10, and I want to sort this. Now you see that in order to sort this array, I need around 3 and 6 and 9 lines of code here. And imagine that same array is of an string, or if it is of an object, then it is going to be even much more difficult for me. Let's see the same thing with the help of code in our IDE. So here we are, and let's start with our demo 0, where we are going to see the problems with arrays. So I'm just having a very simple demo class with me. Everything is commented as of now. Step by step we will keep on discussing, and step by step we are going to uncomment this. The only reason why I have kept is so that later on when we will be starting with the collections, you can compare very easily without going to any other video or just randomly thinking. So first of all, let's see how we are going to create an array. So in order to create a string array, we just need to say string, square brackets, then we will say array, the variable name, and then we are going to specify the size. Now I'm assuming I just need an array of size 5 here. So I have kept it like this. Now initially, what do you think? What is the data? You can just pause the video and comment. You can comment what is the size and what is the data. And if you have already done, so let's see what is this size. So in order to understand the size of an array, we will just say array dot, and then you will get some methods as well as the variable. So this length is going to tell you what is going to be the size of this array. So let me just save it and run this. So on running the code, we can see the size of array is 5 here. Now let's see what is the data in this array 5. So for this, what I'll do is I'll just try to print the array. Let's see whether we will be able to get the data or not. So I'll just execute the same again, and you can see instead of printing me the contents, it has actually printed me the address of this array. So that is not the right way in order to print the contents. And for this, you may make help of index for loop, or you can go for an enhanced for loop also. So I'm assuming you are already clear with the arrays and we are just revising the concept. So I'm directly going for the enhanced for loop, something like this. Let me just format it a bit. Yeah. And now let's print this out. So you can see that since I have not added anything, but I have just created an array of size 5, so all the values are null. If I would have created the same thing with the help of an integer, all the values would have been 0. For an object array, again it is going to be null. Now let's move ahead and start adding some items here. So for this, we are going to do this way. So we will just say array, and then in the square brackets, we are going to provide the index. Now in Java, for arrays, or later on we will be going for the collections, all index are going to start with your 0. So that is one thing you need to remember. So here we are going to have elements at index 0, then 1, then 2, then 3, and then 4. So the final index is always going to be 1 less than the length of array. So if length is 5, last index will be 0. If length is 10, last index will be 9. So this way, let's put Java at index 0, Python at 1, and C at index 3. We are not keeping anything at index 2 and 4. Let's see what it does. So now again, okay, I have not printed the content. So let me do one thing. Let me copy this for loop here. And before that, let me also copy the length so that you won't feel that, okay, it has increased the size. Now let's see what it does. So you can see now the size is still 5 and the contents are Java, Python, then null, because we didn't added anything at index 2. Then it is C, and then again it is null. So this is the way you can add data to your array. But as you can see, there are chances that some space is going to be wasted here. Now let's see how we are going to fetch the data from this array. For that purpose, you just need to make again help of index only, and you can just say array2, so it will give you the data at index 2. So what do you think what it is going to be? So we can see it is null and not Python, because again remember, index starts from 0. So 0 is Java, 1 is Python, and 2 is null here. So this is the way we got. Now let's move further and see how we can modify the array here. So for this, I'll just do it this way. So what I have done is I'm just going to replace the content. There is no other way to modify, and you just need to replace it this way. So we are just saying go, and let's again print the size as well as the contents. So now you can see it is Java, then go, then null, C, and then again null. So what do you think? In reality, will go replace Python anytime? That can be debatable. And now let's move with the next one, how to remove the data from array. So for that purpose, again, we don't have anything specific in nature, but we will just simply say array1. So let's say I just want to remove this go from here. So I'll just replace it by null. If it is for an integer, I'll replace it by 0, or we can assume it to be a -1 also. For objects, again, we can say null, and you can see it is Java, null, null, C, and again null. So these are some of the common operations. Another common operation we are going to do with the arrays is of sorting the elements. And as you saw in our PPT also, it is going to be a tough job. So we have done the tough job here. So what we are going to do is, first of all, we are going to take an outer loop, then an inner loop, and then this time we also need to check for the nulls also. So here we have some null check also. Since it is a string, we can't just say greater than or less than. We need to make usage of the compare to of string. So that will compare and return us an integer depending whether the first string is bigger or the second string is bigger. And here it is by default going to use the ASCII values of these strings. So that we are not going to discuss much in detail, but as you can see, the sorting is going to be a little bit difficult here. And instead of string, if it is a sorting of an object, then it is going to be even much more difficult, because then you need to think on various variables and something. So that part will remain difficult. And if I execute, so you will get data like this. So earlier, if we compare, we were getting Java first, then null, null, C, and null. But now I'm getting C first because the ASCII of C is less than Java. Then I'm getting Java, and then all the null values are coming at the end. So this is the way to sort your array. And again, you saw it wasn't easy. You need to remember such a big logic whenever you need to sort. Again and again, you need to repeat the logic multiple times. You may say that we will create a method, but again, then if it is an object, so for that you need to create so many methods and it is going to become difficult. And one of the last thing, let's see what can be the exceptions here. So as I mentioned you that here the last index is 4. So by mistake, if you try to put something at array index 5, or let's say you want to fetch the index 5 or any bigger index more than 4 in our case, so you will be getting some kind of exception, and that is this. So it will say exception in thread main. And you see why is it saying thread? So I hope you have watched our multi-threading video. So if you have watched that video, you will come to know why is it saying thread main and not method main. Then it is giving us array index out of bounds exception, and this is the one. Now I'm not sure by this time we have already created a video on exception handling or not. Depends on when you are watching this video, but again you can check our channel. So there you must find some video on exception handling. If it is not there, then it means we are going to create soon. So it will provide you an exception like this, and hence we say that working with the arrays is difficult. It is not that easy. And because of this reason only, we need to talk about collections in Java, or going by the exact term, we should be saying collection framework. So now let's talk about what is collection framework or collections in Java. So the definition says a collection framework in Java is a unified architecture or a framework that provides a set of interfaces, classes, and methods to store, manipulate, and retrieve a group of objects or elements in a structured and organized way. The collection framework provides a set of standard data structures such as list, queue, set, map, and provides a set of operations to perform on these data structures, like adding the elements, removing, iterating, searching, sorting, and many other operations. So here you will see that we are going to use the word framework here. Framework, simply in the normal terms, we will call it as architecture. Why do we call it as a framework? Because here we have a particular, you can say, a group of interfaces, and then for those interfaces we are already having multiple implementation in form of various classes, and then those classes are already containing methods. So those methods are like how you are going to add some data, how you are going to remove the data, how you are going to iterate, how you are going to sort. So most of the common things which you feel that they are going to come in your coding, everything is already there. The only point is you just need to use them as per your requirement. And under this collection framework, it is not a single collection, but we are having a list also. List means that something in a particular ordered way. If you say I don't want in an ordered way, you can go for a set also. So we have sets also. Then we have something as map also, which is something like a dictionary in your Python, where we have a key and value pair. Then many times we just want a queue also, where we call it as FIFO, first in first out. So we have queues also here. So we are going to see all these things in detail in our next demos, and we will see the most common operations also. One thing which we are not going to cover here is the internals about list, queues, and maps. So this video has been created by keeping in mind that you are reading the collections for the first time and your goal is to use them in your code. Here we are not going to in a detail that how the hash map is going to work or the set is going to work, which is one of the general questions in your interviews. So that kind of things we can cover in some other video, otherwise it will become very long. Now, before moving directly with the collections, you will see that we are going to use two keywords here very commonly. One is collection and the other one is collections. So first of all, let's see what is the difference between collection and collections. It is not normal English that you can say first one is singular, the second is plural, but here it is having some deeper meaning. So in Java, collection is an interface under the collection framework. So we call it as a collection framework. You can assume framework is just an architecture under which we have a collection, which is basically an interface. Since it is an interface, so in order to implement, you need some classes. Now, It is going to provide you the basic functionality like adding, removing, or iterating over the elements. And then we are going to have multiple implementations for this, like we have a list, we have a set, we have a queue. Why I'm not putting map here? Because that is out of the collection. That is not a child of collection, but a part of collection framework. So that is collection. The other term is collections. Now this collections is a completely separate thing, which is just a utility class. It is just going to provide you some static methods which you can work with the help of collections. Those methods can be sorting, searching, and shuffling. And common methods are going to be collections.sort. So remember, when we say the term collection framework or collections, then there the term collections we use of the English collections, which simply means a group of something. Here, collection is the parent interface for all those things like list, set, and queue. And collections is just a separate utility class which we will be using along with our collection. So before confusing you, let's directly jump in here and let's see how this collection framework hierarchy looks like. So as I mentioned you, this collection is an interface, and you can see we have an E here. Now if you don't know the meaning of E, then first of all that's not good, because this simply means that you haven't watched a video on generics in Java. So you can still pause the video and you can watch that one first, because that we can say as a prerequisite for understanding collections. It's around 1.5 hour video, but everything is explained in detail, which is going to help you here. And if you already know about this, then you know that we can replace this E by any element at the runtime. So everything which you can see in the yellow color is an interface. So first we have a collection. Under this we have a further sub interface as list, where you will see everything in the ordered way. Then we have a queue. Now the difference between queue and list is that in list we have indexes, everything is an ordered way. If you wish, you can in between remove something, add something, but in the queue here we don't have index. Here also it is ordered but without index, and here we are going to follow first in first out, that is FIFO approach, and that is queue. And then we have something like set, which is a completely unordered group. There is no index and there is nothing like FIFO or anything. It is just, you can say, a bag containing some items. Now we can't directly make usage of list, queue, or set here, and hence we have some implementations here. So for list, commonly we are going to work with the array list or linked list. The difference between two I will tell you when we are going to start with the code part of this. Then for the queue, you can again see there is again a subpart which we call as deque, or you can even call it as a DQ, but more better is deque here. So we say queue is one where you are going to add elements from the tail and get the elements out from the head, first in first out. DQ is you can add or remove the elements from the back as well as the head. So DQ is just a subpart of queue, but we are going to see. And again, since both of them are interfaces, so they can be implemented with linked list. So same linked list can inherit list as well as deque, because you know in Java classes can implement multiple interfaces. So that is the benefit, but since some methods are different, so we will study linked list for this queue again. Then for set we have multiple implementations like hash set, linked hash set, and a tree set. We are going to see with the help of code what is the difference between these three, and I hope you are guessing right that we are missing the map. So map is here, and this map is a key value pair, guys. So this is not a child of collection, but overall it's a part of your collection framework. Here we are going to have different methods, like for list, queue, and set. You can see that we are going to have common methods in future, but for map it will be something different, because this map is something like a dictionary where you are going to have a unique key, but you can have multiple or duplicate values is possible. For maps also we have something like hash map, linked hash map, and tree map. We are going to see all these things in detail very soon. Now let's try to understand more about collection framework. Now for this purpose, first of all, we will be starting with the list. Now under list, first of all, we will be seeing the common methods of list. Then we will see how we can iterate over the list for the simple for loop and a for loop, or is there something different also. Then we will see how to remove integers from the list. Now why I have taken integers separately, that you will come to know very soon. Then we will see what are the various types of list, what is the difference between the array list and the linked list here. Later on we will see how to create a list from an array, how to create an unmodifiable list, and at the end the most important thing which you are going to use commonly, that is how to sort objects in list, or how to create a list of objects, because in reality you are just not going to work with a list of integers. It is going to be a even more complex thing, that is with object. So that we are going to see at the end. So now let's jump towards our IDE and see all these things in detail. So here we are guys with our demo 1. Again it is created with Java 17, and let's see all these examples one by one. So you can see multiple examples are there, and we will try to fast forward it a bit. If you feel I'm still slow, so you can increase the speed of the video to 1.5x or 2x, that is possible. But let's make it simple. So first of all, let's see how we are going to create a list. Now in order to create a list, you will be using something like this. Now what is this? Again it is coming from generics. You can have a look for our video on generics in Java and see why I have written like this, why I have not written here, and how we are getting a list of strings. So this list, as you know, this is going to be the parent. So for this you just need to say here Control Shift and O. So the moment you will say Control Shift O, you will get an import of list as well as for the array list. Now you can hover over to your array list, you can say open declaration. So you will see that this array list is basically a class, as I mentioned you, and it's a generic class. We are not going to discuss about abstract list and everything, but we will just say that this array list is a child of list, and this list is again an generic interface, and this is a child of collection. The collection is the same which I told you in the starting, the common interface under your collection framework. So that is your collection, and all these are generics in nature, because of which you can make them for anything. If you want to make them for string, do it like this. If you want to make them for object, just put the object, which we are going to do in our last example 7. If you want to do it for integer, we will do in our example 3. So everything is here, but I am not going to tell you what are the other advantages of generics. For that, obviously you need to watch the video, and maybe you can see the I link on the top here. So this is the way to create a list here. Now what is the size of this list? Let's check out. So for this, what we have is, we have something like the method size. You just need to say list dot and say control space in your Eclipse. So we'll see list is going to provide me so many methods. So all the methods are there, and it is not possible to cover all of them in a single video, and neither you need to learn all of them. Even I don't know all of them at all. So only the basic methods we are going to discuss. Rest, whenever you need, you can just study them. It's very easy. So now let's say if you want to know what is the purpose of this size, so just hover over this, and you can see this is going to return number of elements in the list. So this way you should also make a habit to learn the description, to read the description of the methods or the classes which you want, so that you can always make the usage at the runtime. So this will print the size. Now if you remember, for the array the initial size was 5 because we made. Now here I haven't written anything, so what is going to be the size? Let's see. So I'll just run over this, and you can see the size is 0. That is the best part. Initially size is 0, and that means whenever you wish to add anything, the size will just keep on increasing, and hence we call it as dynamic in nature, dynamic size, or you can even call it as flexible. Now let's see what are the contents of the list. So you saw that with array, when we just tried to do it directly, it was printing the address of array. Let's see what it does. Currently it doesn't have any content. So it says me something like this, empty square brackets, which means it is not printing me the address of the list. Instead, it is trying to print me the contents. That's a separate thing, that currently it is empty. So we are getting empty brackets, but it is that easy to print the contents of list. You don't even need any enhanced for loop or index for loop or anything. It's that simple. The only disadvantage is you are getting the square brackets, but that's fine. Here even we are little lazy, we are not using any for loop or anything. So till the point you just need to see the contents for some time, you can make usage of this simple. Now let's see how we can add the items and where are they going to be added. So as the statement says, the items are always going to be added at the tail, which means always at the end. So the way to add is, we will just say list.add. Here you are not going to directly work with the index, but you can just make usage of the method add here. The moment you will say add, it will be just added. So again, this is going to start with your index 0. So first it will say 0, then 1, then 2, and so on, and it will keep on increasing. So we will say list.add, it will simply add, and it will also return you a boolean value. As of now we are not making usage of it, but if you wish, you can check out for some purpose also whether the item has been added or not. It can notify you by this way. So first let's add Java, then let's add Python, then say C, then let's print the size, and then let's print the contents of the list again. So again we are going to run this, and now you can see the size is 3. So earlier it was 0, now it is 3, and the contents are Java, Python, and C. Without any for loop, I can print the contents, and that's easy also for me. If you say no, I don't want the square brackets, then you can go for the for loop, which we will see in our example 2 there. Now let's move ahead and see what if I want to add any element at a particular index. So let's say Java is at index 0, Python at 1, and C is at index 2. Now I want to add any element at index 1, but I don't want to replace Python here. I just want to add a new and shift Python by one index. So for that you can do something like this, list.add. Again there is one more add method. First add method is only going to take the data. Second add method is going to take the index as well as the data. So for the list, again you can check out here. So both the add methods here, and here you can read their description in detail. So what it will do is, it will add SQL at index 1, but it won't replace Python. Instead it is going to shift Python by 1. Now imagine the same thing if I ask you in arrays. It will be very difficult. First of all you need to do the shifting, and then you need to do the addition. So what it did, it simply increased the size to 4, shifted Python by 1, and added SQL here for us. Next thing is how to fetch the item. So that is also very simple. We just need to say list.get and put your index. So let's try to do it like this, and you can see the Python is there. Element at index 2 is Python, 0 is Java, 1 is SQL, 2 is Python, 3 is C. What do we have on 4? Let's try to print at 4 also. So let me just do it like this. So you can see if I say 4, it will simply say me index 4 is out of bound. So currently the size is 4, which means maximum index can be 3. If you will try to say 4, it will be again an exception. First you need to add element and then only add the item there. So this is not possible, guys. Now let's move ahead. Now what we will do is that many times, let's say you know the element, but you just want to know that at which index that element exists. So for that purpose, if you know element and want to know the index, so you can say list.index of and just put your element there. So I want to know what is the index of Python here. So I will use index of Python. It will say me 2. Now if I make any mistake here, let's say I write an extra E here. Now I know that Python is not there. Let's pronounce it by Python. So let's see what it will do. Will it give me an exception, or will it just say me 0, -1 on an exception, or maybe it would do anything. Let's see. So here you can see it is printing me -1, which means -1 denotes the element is not there, because in reality you know that there is nothing like index -1. So here -1 simply means item doesn't exist. So you should remember it. So this is the way. Now you can even make few more experiments with this. You can see what will happen if I say -1 here. I won't be able to do everything here. Yeah. Now the next requirement is I don't want to add a new element. Instead, I want to replace this SQL by Go. So that means you just want to modify. For this, we can make usage of set method. Set will take an index, an element. Add will add a new element. Set will just replace the element. So let's do that thing and execute. So you can see now it has replaced by Go. SQL is done by Go and size is still 4 with us. Now let's see how to remove an element. So that is again simple. You just need to say list.remove. You don't need to remember everything, but even the basic method should be remembered like this. Otherwise you can always say list dot, and here you can just think of it. I mean, in order to remove, what can be the method name? Either it can be delete or it can be remove. So let's see, we don't have anything delete here. So let's go for R. So there is an remove R here. So you can remove by index, you can remove by object also. Since we have passed the object here, so it is going to replace by object. So let's see what it does. So earlier we had Python, now we don't have Python, and it has decreased the size to 3. It is not replacing by null, guys. That's the again benefit, increasing and decreasing size. Now if you also wish, you can remove the element by index, and the method is same for this. So in the same method you can pass on your object also, same method you can pass on your index also. The reason is here, so it is an overridden method, or sorry, not overridden but overloaded method. So I hope you know about the overloaded methods in Java. And again let's see, so what was at index 1? So at index 1 we were having Go here. So now the output should be Java and C. So this is the one, Java and C only, guys. Now next is, many times you just need to see whether your list is going to contain some item or not. If it contains, maybe you want to perform some operation. If it doesn't contain, you can just ignore it. So for that purpose, one option was you can again make usage of index of. You can say index of. If it is there, it will return you the index. If it is not there, it will say -1, which means it's not there. But you don't want index, you just want to get answer as true or false. So that way, let's say we want to search for an item Java. So what I will do is I will make it something like this, and I will say here list.contains. So in the contains you can say what object you want to search. So here it is going to take help of the equals method, and in string, you know, whenever we are going to use the equals method, it is going to compare the contents. So if it is contains Java, it will print, otherwise not. Contains give you a boolean answer, hence I have taken it in my if condition. So I'll execute and it will say list contains Java. If I will put something else, let's say I will make a spelling mistake, it won't even print that statement because answer will be false. Now let me just format it a bit. Now let's see, what if we want to clear the list? I just want to make it empty. So what should I do? Shall I run the remove method again and again? But that will be too difficult. So the answer is simple. You can just simply say here list.clear. Now what does list.clear will do? Will it replace all of them by null, or will it make size 0? Let's check out again. And you can see clear list means it will make the size as 0 and it will empty everything. And you just need to say list dot clear. Now many times you need to check whether the list is empty or not. So you can see, obviously I can do that with the help of size. I can see size. If size is more than 0, it means it is not empty. If it is 0, it is empty. But why to take size when you have a default method as is empty? So you can just say is empty. You don't need to give any other condition because it simply gives you a boolean. So if it is empty, it will print it is empty. Otherwise, it is not going to print this statement. It's that simple, guys, here. So you can see list is empty here. Yeah. Now let's move next. So what if we want to add multiple elements in our list? Then what to do? Now, then also there is an option. You don't need to call add method again and again. So what we will do is, first of all, let's create another list. Now here I'm making usage of arrays, but this is not array. This is arrays because we don't have any class like array. This is a separate utility class which can provide you a list. We will talk about this in few minutes in our example, maybe 5 or 6. But till then, just assume it is going to provide you a list which will by default contain some data because we have added. So let's say I want to add JavaScript, C#, and Java again. So I don't need to call 3 add methods. Instead, I can simply say list.addAll. So this add all will take a collection. So this is the collection parent. Now you can add any child. You can add a list here, you can add a set here, you can add a queue here, you can add whatever you wish. So it will simply add all the items at end. And now let's see what will be the size. So earlier it was empty. We just made it empty by using clear. And now we are adding 3 items. So let's see what it will do. So you can see now the size is again 3 and 3 more items have been added. Previous have been deleted. So you can add any number of items. So here I have created a list on my own. In reality, maybe you will be getting the list from someone else. So you can just say add all and it is possible. And it is not the case that only if it is empty then you can add all. You can add at any time. Now the next one is, what if we want to add multiple elements at a given index? Again possible. You can add with the help of index. So with add all also, we have also the option of adding at a particular index. Maybe I haven't mentioned the index here. So let's mention. So what index do you want? So we have JavaScript, C#, and Java. So JavaScript at index 0. So let's add them at index 1 here, guys. So I'll say 1 comma list 3. And it's that simple. Add all. First is index, second is your collection. And let's see what it will do. So now the size should be 6 because 3 were there, 3 more I'm adding. Let's see whether will it repeat Java or not, because Java already exists. But it's a list, so it should repeat. And yes, it is repeating. So it is JavaScript, Python, Java, C, C#, and again Java. So the last one is your previous Java. This is your new Java, which we have just now added. Size is 6. So list can contain duplicates. What if you don't want duplicates? Then we will go for the sets, and you need to wait and you need to watch the whole video, or you can just fast forward it a bit. Then now let's see the most interesting thing, sorting. So earlier you saw that in order to sort a string array was so difficult. Almost it was like 7 to 8 lines were there. But here things are this much easy. You just need to say collections.sort. And this is collections, guys, a separate thing which I was talking about earlier. Collections is a utility Java class which is going to contain some static methods. Let's see it a bit. So this is a class, guys, and here it contains multiple methods. So many methods are there: shuffling, swapping. You can swap 2 items, you can copy from here to there, you can get minimum, maximum, you can rotate, you can replace all, index of, and so many things are there with your collections. So it's a kind of utility which you have got by default in your collection framework, which you can use. And let's see how is it going to sort. So earlier it was JavaScript, Python, Java, C, C#, and Java. Now it will sort it on the ASCII. So first it is C, then C hash, then Java is coming twice, then JavaScript, and then Python. So it's that simple. Collections dot sort, and remember, sort is going to take a list. Sort will not take a collection. It will only sort your list, nothing else. And internally it is going to make usage of the compare to method. Then let's move ahead and see the next thing. So the next one is exception scenario here. So let's see. So here I'm making usage of add here, because for the get I guess I have shown you earlier, either for the get or remove I had shown you earlier. So now you know that I can just pass on index and add anything. Now my indexes are currently 0, 1, 2, 3, 4 until 5. What if I add something at index 10? So what will happen for index 6, 7, 8 and 9? So Java will ask you first, what should I do with those index where you're not adding? Now you can't say that make them as empty. It's not an array, it's a list. So it will just give you an error that you can't do this. You can use any index, but the index value can be the maximum next amount. So currently it is indexed at till 5. So index 6 is allowed. But if you will say index 10 or anything bigger, that is not allowed here, guys. So these were some of the common methods of list, and we have seen them with the help of array list implementation. Same things are going to work with your linked list also. There is no much difference. There is some difference in the terms of performance, which maybe we are going to see in our example 4. So let's move ahead. I hope this much is clear, and moving ahead, let's go to our demo 2. And you don't need to worry, all these things you will get from the GitHub. So I'll upload all the demos there. You can download and you can change the contents. You can do whatever you wish to them and you can learn more. Now let's see how to iterate over the list. So for this again we will be using array list, same example, and the first one is already there. So as you know, since it is an array list, we are having indexes here. It is starting from 0. So we can make usage of our simple for loop. So I can say a simple for loop, index starting from 0. I don't need to mention the size there directly, and that is also not a good practice, because later on if the size will increase, you need to change it again and again. So always better to go for the size method there instead of hard coding the sizes 3, 4 or 5. And then you can say you can print the index also and the content also with the help of get method. Remember, this is the same get method which we just used in the previous one. So I can print this and the output will look to me something like this: Java, Python and C. So if you don't want square brackets, you need to do this much amount of hard work with index. Now you say that what if I don't want to use index? Can I go for an enhanced for loop? The answer is luckily yes, you can go for it. So that is also simple. The same way you are working with the array, you can work with your list. Just put your list here instead of array. Since it is a list of string, so make string. This time the only disadvantage is you won't get index, but that's fine. You don't want index, you just want to iterate over this. So again this one is simple and will give you the same answer because list is same. Now beside this also we have something like iterators here. So let's see what is iterator. First I will show you with the help of code. Then I have something video also, a small kind of presentation also for this iterator to show you how they are going to work in reality. But first let me show you here. So what we have is we have something like iterator. So this list only will give you a method iterator. Now what is this basically iterator? Iterator is a kind of interface. So you can assume it to be a kind of a pointer which is going to point your collection, not only for list but the overall collections. It can be anything. So irrespective of the implementation, whether it's a list, set or map, you can make usage of iterator here. Yeah, and with the help of iterator you can iterate over your list or whatever your collection is. Iterate, or we can call it as traverse. Now here we will be making usage of a while loop, and in while loop we will say has next. So what it will do is it will check whether it has a next element or not. If it is having a next element, it will return you true, a boolean value. Now if the next element is there, you will hover over to that and you will point it with the help of next. So by next you are going to point it. So if it is a string, string will come out. If integer, integer will come out. If it is an object, object can come out. So you can simply use it like this. The output is same. The only difference is this is something, you know, more relatable with the collections. So that's the only difference, and these are the things. Now this is a common iterator which can work with any kind of collection. Now what they did was, the Java people, they created one more iterator which they started calling as list iterator. This is also same only. The only difference is this can work only with the list. So your iterator can work with any collection, whether it's a list, set or map. List iterator will work with your list only. The working is still same, has next and the next method. So the output is also going to be same for your iterator and list iterator. Then you will say me, then what is the advantage of making a separate thing? The advantage is that with the list iterator, you can move in the backward direction also using has previous. So with the has next, you can move forward. With has previous, you can move backward. And here instead of next, you will say previous. So let's see. So here we are. So with the help of iterator, first we went in the forward direction, Java, Python, C. Then we are moving in the backward direction, C, Python and Java. So that way, list iterator can move in both the directions, forward and backward. But iterator can move only in the forward direction. It cannot move in the backward direction. And this enhanced for loop, you already know that this can work with your collections as well as your arrays also. Now let's see the same iterator with the help of a small presentation here. So here we are guys, and we are going to see how the iterator is going to work. So I have taken the same code, iterator for the string, and here also you need to mention for which are you creating the iterator. If your list is of string, iterator is also for string. If your list is for integer, iterator is also for integer. Same for any other object too. Then you will say has next, which will give you a true or false. You will say next, which will point. And once the while loop is finished, I'm not using any kind of braces because only single line is there. So once the list is ended, it will print me end here. So let's see how this is going to work. So we have a list of Java, then Python and C. Arrows I have just used in order to mention that okay, this way it is going to move only for that purpose. So 3 elements are there. So when you say list.iterator, it is going to create an iterator object for you. Now when you say iterator.hasNext, it will check whether there is a new element or not. And initially this iterator is not pointing your index 0. It is even pointing somewhere before your index 0. So when you say hasNext for the first time, it will see whether do we have anything on index 0 or not. Since something is there, it will return you true and it will go inside the while loop, where it is going to make usage of the next and start pointing to that particular object. Since it is pointing to that object, you can get the object and you can do whatever you wish. Maybe you can modify that, or maybe you can just fetch it out, or you can do some operation with that particular thing. You can add it to some other list also, or whatever you wish, that can be done. Now again, going for the while loop, it will again see whether there is something more or not. So the answer is again yes. So it will again go inside, and now it will start pointing to Python and it will return you Python here. Then again it will check whether there is a next item or not. It's there, so it will move there and it will start pointing to C and return you the C. So I hope you like this thing also. And now again it will see whether do we have any next element or not. And now you can see there is no next element. The list is ended. Since the list is ended, so it will simply come out and print you end, or whatever the thing is outside your loop, there it will come. So this way your iterator is going to work. Same way, whether it's an integer or an object or whatever it is, but this will be the way. Same way you can imagine for your list iterator also and has previous also, then it will just move in the reverse order. But remember that when you are moving in the reverse order with list iterator, your iterator needs to be at the end, then only the has previous is going to work in a better way, otherwise not. So first you need to go at end of the list and then only you can make usage of has previous. Otherwise, if you will simply make usage of list iterator, it will point to the start, and if you use has previous, it won't do anything and it will print empty. So I hope that was clear to you. And let's see, and what I was telling you is something this. So let's say if I will just create a list iterator, I won't move forward, so I won't do that, and I will just say has previous. Now what will happen? Will it still print me the data or not? Let's see. So this time it will never print me the data. So you can see using list iterator backward is having nothing, because your iterator was by default pointing in the starting. You need to take it to the end first somehow. So here I have taken it with the help of has next and this next only, but there can be other way also which you can just try out. So that's it for the iteration, and now you know that there are 4 ways you can iterate over your list. You can go by the index loop, enhanced for loop, iterator, or the list iterator also, depending on your requirements. Out of these, my favorite one is still enhanced for loop. You can comment me your favorite one also. Now let's go for the next demo. Now in the next demo, what we will do is, it is just a very simple thing, and here we will create an integer list. So as you know, I can't make usage of int here because these generics use only wrapper classes, and hence I need to say integer, not int. So this is one of the things, and when I will print the contents, the size is obviously 3. It will just print me contents also as 1, 2 and 3. Now why I have taken it as a separate example? Because if you remember, when I was using the remove method, that is only my concern, rest everything is same. But when I was using the remove method, you know, the same remove method can take your index also, and same remove method can take your object also. So now what do you feel what will happen here? When I will say remove 1, will it remove the item 1 or will it remove the item at index 1? If you say it is going to remove the item 1, so the output should be 2 and 3. If you say no, it is going to remove the item at index 1, then it should be 1 and 3. So let's see what it will do. So the rule is, by default, when you just pass on a number in your integer list also, then it does something like this. It considers at a index only, not as the data. So this is the major point, so that it can work with your string also. So if you will just say 1, it will consider it as index, not object 1. So you will say, then how can we remove the object 1? So for this you need to tell it the object, and that you can do with the help of integer here. So you need to say integer dot value of 1. So now it will become an integer 1 and the object, and now it will show you just 3 because integer 1 is deleted, and now we are left with 3 only. So this is a very small thing which you need to take care. It can be asked in any interview or any quiz also, and you can make a mistake here very easily. Remember, if we just say 1, so whether it's a string or an integer or any other object list, it will remove by your index. If you want to remove by object, so for others it is simple, and for integer or any other thing you need to say integer dot value of. Direct will never work. Now let's go for the next one. On the next one, we will see the various kinds of list, and as you know, there are 2 types of list, array list and linked list. Now the way of creating them is same, the methods are also same, there is not much difference. Then why do we have 2 implementations here? So there is a small difference that the array list are going to use arrays internally. On the other hand, the linked list, they can inherit your list also, and they can inherit your queues also. And hence they are not going to make usage of arrays internally. They are going to make usage of some links. Here, it is not necessary that all the data is in the same place or they are occupying the same memory space. Here, maybe first item can be at some particular memory, second item can be some other memory, third item can be some other memory, and with the help of links, it is going to point to the next item. But in the array list, they will take the same place. Now, how they are going to be different in performance, let's see. So for this, what we will do is, we will be making something like this. So first of all, we will take help of nano time. So this system represents our machine and we will say nano time. This is not a part of collections. So what it will do it will give you the current time in terms of nanoseconds, which I'm going to save here as my start time 1. Then what I'll do is I will be adding almost 1 lakh items here. So you can see I have added 5 zeros after 1. So it is 1 lakh items. So I will be adding almost 1 lakh items in my list. So I will just go for a for loop here, indexed for loop, and every time I will just keep on saying array list dot add I. I don't want to print or do anything. I will simply add them. And then I will just take the time again. I will identify the difference and then we will say that how much time it took for this addition or modification. So it can be your addition also, it can be some modification also. So we will see how much time it is going to take for 1 lakh items. And the same thing, this is just a repeated code, we will be doing with the linked list also. And we will see the difference that in adding the items to the list, which one is faster when you want to do any kind of addition or modification. And remember, it is for 1 lakh items. So you can see the difference, and the difference is visible clearly only when you go for bigger number of items. If you will say 10 or 20 items or even 100 or 1000 items, then it is negligible. Then you can go for any kind of list. So let's see here. So first of all, let me clear the console and let me just click and see. So you can see when I execute, the output is really quick. It didn't even took much time even for 1 lakh items. And you can see the array list took me something around 8448 and then 200, which you can say is count to be something like 84,48,200 nanoseconds. So that much amount of time was taken by your array list. On the other hand, your linked list took only 44,95,100 nanoseconds. So you can say that for the addition purpose, when the requirement is to add the items again and again to your list, it is always better to go for the linked list. So hence this one is better. Now let's see the same thing with the help of our getter method also. So this time again I will just say start time 3 and here I will just end it. And this time what I will be doing is I will be just getting the item from the list. So again I'm not printing because that is not our goal. Our goal is just to see the time difference. So for all those 1 lakh items we will see first for array list, then for the linked list, and I have taken all the conditions same. So for each and every operation I'm starting the time again and again, ending the time again and again, and code is always reused here so that you won't say that it took some time for array or some other purpose. Yeah. So let's see. So the code is still running, guys. Yeah. So you saw this time linked list took time. So in order to fetch the items, your array list took only 12,40,300 nanoseconds. On the other hand, linked list took even much more time, and it is like 35,000, this is 64 lakh, and it is 321 crore 64 lakh 35,500 nanoseconds. Such a big time. Why? Because whenever you go for the array list, So what they need? They basically need all the memory in a particular place. They can't say that one item here, some item somewhere else, some item somewhere else. Hence, when you are adding or modifying something, then it wants all the items at a single place, and hence it is taking more time to add the items because it may need to free up some space, it may need to allocate or deallocate the space. So it took more time. On the other hand, linked list can just keep the items at any places and it will do with the help of linking. So linked list addition was faster as compared to the array list. But now when it is time to access those items or traverse over those items, so you know that in array list you kept everything in a single place. Since you kept everything in the single place, it is easier to iterate over them or check out anything. So that was faster. But your linked list, they thought that okay, I will keep something here, something there, something there. So they need to point from here to there, and hence it is more time consuming, guys. So that is the basic difference between your array list and linked list. And also remember that this difference will be observable when you will go for a big list only. So let's say if I will just go for a very small list of just size 10, then it won't be observable. You can say it is negligible. There will be some difference, but we can't predict anything out of this because the data is very small. So whenever you want to test anything like this, always go for the big numbers, then only it is going to be theoretically clear to you. And I hope the reason is also clear and with the numbers is also clear. And if you feel there is not much data, then it is fine, you can go for any of the list. You don't need to worry much here. Yeah, and otherwise you can decide depending on what kind of operation you want to do. If you feel only additions are there, frequent additions are there, go for linked list. If you feel no, additions and retrieval is also there, so depending on those things you need to identify on your own. Now let's go for our next demo and let's clear the console. So in the next demo, what we will do is we will see how to create a list from the arrays, something which we saw earlier also. So here we have a array in the starting. So we have created a string array with us which contains Java, Python and C. Now how to create a list from this? So you can just say arrays dot as list. So this is simply arrays dot as list and you can pass on your array here. If you already have an array, you can pass. If you don't have an array, so you can directly put your items there. Now don't get confuse it with your array list. So this is not your arrays list. Here you have created a list from your arrays. So this is something different. Now how is it different is that this list is currently backed by your array. Now what does it mean? We will see in some time. But currently just remember the statement, the list is backed by an array. You didn't create the list from scratch. You created the list from an array. So what we will do is first of all we will print the contents of list and then we will print the contents of the array. Obviously they will be same because we have made it from the same thing only. So this is your list, this is your array data, same Java, Python and C. Now let's see what happens if we modify something in our list. What will happen? So in the list I will replace the index 2 with SQL using the set method. So that I'm doing. So now let's print the list and the array. So I'm not changing anything to array, I'm just changing the list. So let's see. So you will see that on changing the list only, it has changed your array also. So in array also it has replaced as C by SQL. Why? Because it is backed. Here array and list are interlinked with each other. Whatever the change you will do in your list, same change will happen in your array also. So modifying a list will modify your array also. Now let's do the reverse and see whether the reverse will also give you the same answer or it will give you the different answer. So let's see. So this time what we will do is, okay, modifying array will give you list. So let's not make a change to your list, and instead let's make a change to your array. So in array, what we will do is, currently we have Java, Python and C. So let's replace your Python with some other language. Let's call it as JavaScript so that you don't get confused. So we will replace Python with JavaScript here. And then let's see what will it change. Will it just change the list or both the list and array or what? So when you replace or you modify your array, you see your list is also modified. So it will replace Python with your JavaScript, which means they are completely interlinked and dependable on each other. Any change in your list will change array. Any change in your array will change your list also. So this is, you can consider it an advantage or a disadvantage, but I will call it as a feature of creating list from your arrays. But this is a quite handy feature when you already have some data. Yep. And now let's go for the next. Now what if we add a new element to the list? Then what will happen? Will it allow to add me? Because the rule says that lists are expandable in size. You can increase or decrease the size. So that is the law of list. But this list is backed by your array. So if I will try to add anything to the list, it will get added to the array also. So the array law is violated. So let's see what will happen. So this will result me an error. Unsupported operation exception. So this means that it is possible to modify list, it is possible to modify array, but you cannot add any new item to your list. And there is no chance of adding new item to your array because you know that is already of fixed size. So this one is not allowed when you work with your this kind of list. Then the next thing, is it possible to remove? Again think, both of them are backed with each other. If you will remove from the list, it will remove from array also. It will change size of array, which is again not allowed. So when you will say remove the element from the list, so this is not allowed, but it is not throwing any error. So what does it means? Let's try to print the contents for both of them. So after removing, let's print the content because it didn't throw any error. So let's see. So we see it has not even deleted, or okay, C hash was not there. That is the reason that it didn't throw any error, because it was not even there. So this remove will give you a boolean value, true or false. If the item is not there, it will never throw an error, just give you a false. But what if I say I want to remove Java, which is there? So if you want to remove Java, then that is again not allowed, because if you will remove Java from your list, it will change the size of your array also, which is again not allowed. So hence you cannot remove also from your this kind of list. And the last but not the least, what about clear method? So I hope that is also clear. Very simple, that if you will clear the list, it is not allowed, because this will make your array also clear, and again that is not possible to clear anything in your array. So that simply means that you can modify the data of your list, but that doesn't mean that you add, remove or clear your list when you have made it with the help of arrays. Yeah. So this is the kind of a feature for this. Now let's go for one more thing, that is unmodifiable list. Now you will say that whatever we did just now, that was unmodifiable only, but that was not the thing. You cannot add or remove anything, but still you were able to modify the content. What if I say I want a list which you can never modify, something like a final kind of a list where the data cannot be changed? So for this we will be working with something like this. There is an off method coming from your list. So this off is a static method, and here you can directly put whatever you want. So you can just put the items here. If you say simply off without anything, that means it's a list of size 0, but an unmodifiable list, so you cannot increase or decrease later on. If you will just start adding the elements, at that time. So it is the only first and the last time when you can add the data to your this kind of unmodifiable list. Later on you cannot do anything with this. So first of all, let's see the size, and the size is 3 here, and the contents are Java, Python and C. Now let's see, can we modify this? So obviously the modification is not allowed, not even setting. So with the arrays, setting was allowed, but here even that is not allowed. So setting is not allowed, and simply I'll quickly show you that this adding is also not allowed. So this adding is not allowed, and if you just trust me, then you can assume that removing is not allowed, and similarly your clearing is also not allowed here. So when you are working with anything like this, a list.of, so it's a completely unmodifiable list, no clearing, no removing, no adding, no kind of modification is allowed here, guys. So that's it with your modifiable list. And now we are heading towards our last example, that is for your list containing the objects. So here in our last example we have done something like this, but first let me explain you about this employee. So I have created it here. So this is my employee class. It can be any complex class in your real world project. Here it's a simple one. So I'm having an ID which is an integer, a name which is a string, and this is your employee parameterized constructor. We have two getter methods and we have a toString method here, guys. Simple. Now let's go here. So what I have done, I have created a list of employee, then I'm adding 3 employees here, Tom, Dick and Harry, in some random IDs, and now I will be printing their contents. Since I have overridden the toString method, so I won't get the address of employees but the content of those employees, something like this. So you can see it is showing in the same order, 20 Harry, 10 Tom and 50 Dick. So these are my 3 employees. Now I want to sort them. So let's sort, and I want to sort them by ID. So you know that for sorting it's simple. For your list you just need to say collections and you say dot, and this collections we will be getting from java.utils, and on this we will be calling our sort method, something like this. And let me just import first. So in this sort I just need to pass on the list, it's simple. So I have passed on that, but it is still not working, guys. Why so? You remember earlier it worked when I was working with the list of strings, but why isn't not working now? The reason why it is not working now is, for that we need to check out the description of the sort method. So let's go there for the sort and see the description. So this sorts the specified list into an ascending order. That is for the natural ordering of the elements, and for the natural ordering your list must implement a comparable interface. So you will say that okay, for this we didn't made anything change earlier, because earlier you were making a list of string. List of string was by default implementing comparable. When you do it for the string or any wrapper class, the comparable comes by default, but when you are making for your own, you need to implement. So this one is here. So here we will say implements and comparable, and this is the first time we are discussing, so no need to worry that you don't know what is this comparable. We have just read the description and we are saying implements comparable. So we will say Control Shift O and Control Shift F. Now for this comparable it says it's a raw type. Now you remember whenever this kind of warning comes, it means it's a kind of generics. So what we will do is we will just put here employee, because we want to compare two employees. So here we will say employee here, that is fine, but it is still giving me the error. So what I will do is I will click here and see the declaration of comparable. So you will see that comparable is basically an interface, a generic interface, and it contains a method compare to. Now with the very basic Java knowledge, you know that whenever interface contains a method, you need to implement it. So we need to implement the compare to method and return something, and this T will be same as this, which means your employee. So what I will do is I'll just click here and I'll say add unimplemented methods. Okay, so it has added here. Let me remove it from here and paste at this position. Let me remove this extra space, and there we are. So this is your compare to method, guys, which can take an employee and return you an integer. And now you will see that your error is no more there, so it's gone. So what we have done is we have just returned 0. So here I'm saying implements comparable because it asked me. Then it was showing me a warning, so I said employee, and then it said override, so I have overridden. Now let's see whether will it work. So if we see, so you see there is no change in the output. The output is still same, guys. That means it is not sorting by IDs. For this you need to tell it to sort by the IDs. If you will just say 0, it won't do anything. So you need to tell it some way. So how you can tell it? By returning the difference. So since we want to sort by ID, what I will do is I will say this dot ID, which means the ID of current object minus the ID of the object which is passed from the argument. So one is my current and the one which is passed here. So we'll say this ID dot o dot ID. Let's execute and see. So now you see this is ordered in a particular way, that is ascending order. So it is sorted in ascending order. So first we are getting 10, then 20, and then 50. So this is the thing which you need to do. You can compare it on any basis. If you wish, you can even compare it on the basis of name. Then you just need to compare the names. You cannot use minus, you need to use the compare to method. And what if you say I want to sort in the reverse order? So just reverse the condition. It's that simple. If the previous one gave you in the ascending, so this should give you in the descending order. So let's execute. So you see it's the descending order 50, 20 and 10. So it's simple enough. Let's revert the change. So this way you can sort your objects on whatever the parameter you wish. If there are multiple parameters, you can make some complex if else condition here. Just remember you need to return integer. Positive integer, negative or 0. 3 integers you just need to return, which will do your job automatically. Now this is done. Now the next requirement is you also want to sort sometimes by name. Now that's complex. Now you will say that okay, if we want to sort by name, so we can just do simple. We can make usage of this collections.list. We can paste it here and we will go to the employee and we will change the logic. We will start using the name instead of ID, but that's not the requirement. The requirement is here I want with ID, here I want with name, which means this is my custom requirement. Now this was your natural requirement, this is your custom requirement. So for your custom requirement, what we need to do is we need to create a comparator. You will say how I came to know. So let me just control space here. So you see there are two sort methods. This one which is your natural ordering comparable, and the second one which is your specific order, and here you need to pass something comparator. Now what is this comparator? It's a particular interface. So let's do something. We will say here new of comparator, guys. So I will say new of comparator. Let's try to pass on here new of comparator. Now you know this comparator is an interface. Now since this comparator is an interface, you cannot directly write it. First we need to extend a class. So let's create a class, guys. So we'll say new and class, and here we'll say let's give it a name like custom employee and comparator. So this way we will say, and let me just finish it. So this comparator is finished here, and now here I want to implements comparator. So this one I need to do, and here also I need to pass on employee because I want to compare two employees. Now again, this is giving me some error. So let me say add unimplemented methods. So here the method is compare. There it was compare to. Here it is compare. This is also returning you an integer only, but this time it is taking both the employees. So we will just say O1 dot get, let's say, name, and O2 dot, and let's say, name. And strings you cannot do like this. So let's see how we can compare the strings. So we will again say dot, and we will make usage of compare. So compare to, and then we will just say something like this O2 dot. So this is the way, guys, for doing the job. So for the custom comparator, you need to write on like this. Again, here also you can your wish on whatever the parameter you want to compare them. So comparator we have created. Let's see how to use it. So for using, now I need a comparator, and the object I have already created there. So instead of saying comparator, I will say custom employee comparator, and I will say Control Shift O so that it gets imported for me. So this is my custom employee comparator which I have done here, and let me just quickly execute. So you can see now it is sorting on the basis of your names Dick, Harry and Tom. So this is the way. By default this is natural order, and this is your the other one custom comparator, guys, which you need to do. Remember that when you go for the natural order, it can be only one overriding. You can override only once. But when you make custom comparator, then you can make any number of custom comparator, whatever you wish, you just use it. It is just like a plugin kind of thing. So this has been done here, guys, and let's close this and let's quickly see the difference between comparator and comparable before we finish our list part. So comparable, as we saw, this is just an interface used for the natural ordering of objects. By default, if you are working with any kind of string or integer list, this is used there by default, hence I am calling it as natural. But when you are working with the objects, then you need to implement this comparable interface, and then you need to override the compare to method. So this is mandatory, and it is again using generics, and this can return you anything like negative, 0 or positive integer. If you will say this minus O, the item which is coming, it will give you ascending order. If you will reverse, it will give you the descending order. The other one is comparator, which is again an interface, but this is for the custom ordering, because even for other things don't use it. Now you can't say that can I use the comparator for the strings, because strings will by default use comparable. If you want to use comparator on string, how can we make usage? Because there it's only content. Sometimes you may want to do it for the size, so you can make usage of comparator, and you can create a comparator for your string also, and depending on their length you can compare possible. Here you need to override the compare method as we did. Both the objects will be coming in the arguments, and depending on your output you can sort in the ascending or the descending way. So this way we have learnt about comparable and comparator also. The implementation you can always change as per your requirement. Now let's talk about Queue and Deque here. So with Queue and Deque, the major difference between this queue and your list is that in your list you have indexes, and you can add anywhere, you can delete anywhere, you can perform any operation whatever you wish. But in the queue, here we don't have an index in that particular way. It is also sorted like your list, but you cannot access any element by index. That is the first difference. Second difference is this queue is first in first out, which means you always add from the end, that is tail, and get the element out from the head, that is from the front. Deque is you can add and delete from the end, and you can add and delete from the starting also. So we will just quickly see few of the methods of Queue and Deque, and we will see how to iterate over them, and we will see that removing integers from the queue, will it make any difference like it was doing in your list or not, although it is not directly working with the index. But let's see how it is. One thing you need to remember, that generally in the coding we are not going to use queue and deque. We only work with list, set and map. So if you wish and you are in a hurry to learn only the main things, so we can skip this particular part also of the video and move with the next part of set. So now let's see the demo of queue here, guys. So again we are doing it in the same way. First let's go here. Now here, first of all, let's see how to create a queue. So we will be creating a queue just by saying this queue here, and I need to say Ctrl+Shift+O to import the queue with me. So the queue is again coming from java.util package. The implementation I'm using linked list only. There is another implementation, priority queue, which we are not covering here, only linked list. Now let's quickly finish this since we have already worked with the list. So first of all, let's find the size. We can reuse the same method size here. Now let's display the content. We can again reuse the method contents. Let's see what is the output. So the size is currently 0. The contents are empty. So this is the one. Now let's add the items. Now this is important. Here in the queue you can always add the item from the tail, that is from the end, not from the starting. So we can say queue.java, queue.python, and then we can say queue.c. Then let's again print the size and the contents. So when we do this, we can see Java, Python and C have been added. So that is one way. And this add method is same as your list also, which you saw there. So here we say insert the specified element into the queue if it is possible to do so without violating capacity restrictions, returning true, else exception also. So here we have not created a queue with the capacity. Many times what can happen is you can create a queue with a particular capacity also. Let's say you are creating a queue of size 2 only, which means you can't add a third element. So in that case, third element will throw you an exception. First two will return you true, third will give you an exception if you will be using the add method. There is one more method which comes with the queue, that is offer. So this is your offer method, just the same way. The only difference between add and offer is that your offer method doesn't throws an exception. Instead, it returns you the false. So in case, let's say your size was 2 only. So for all these elements, it won't return you any kind of exception, but will just return you boolean. On the other hand, add will throw the exception. So that is the difference between add and offer. Otherwise, the job is same, to always add the items from the end. So you may need it from some kind of interview purpose. So this is the one. Now let's see how to fetch the elements. Now here you cannot fetch the element with the help of index. You can always fetch the element from the head because it is first in, first out, and the method is element. So when I say element, so it will just return me Java because it is on the top. There is one more method which we call as peek, and if I execute this method also, it will also return me Java. So both of them are returning me Java. Then what's the difference? Let's see. So the first method, that is element, it says it is not going to remove but will just see and return you the value. It will not remove. Now if the queue is empty, it will throw the error, but the peek method will never throw the error. That is the difference. Peek can return you null, element will return you exception if the queue is empty, and they are not going to remove. And what if I want to try with the help of, let's say, queue.get? So you see there is nothing like get where you can pass an index. So that is not possible here because it's first in, first out. What if you want to remove the element? So then that's simple. You can make usage of the remove method here. Simply and it is going to remove the item, but again remember from the head. So now you can see it has removed Java and it is returning you the next elements. There is another method which we can call as poll here along with your remove, and that will also remove. Java was already removed, now it will remove Python. The difference, so remove method can return you the exception, the poll method will return you null if the item is not there. So this is the difference. The shortest way to remember these things is that you see this remove was common with your list, add was common with your list. So the methods which are common with the list, they can return you exception. The methods which are not common, they will throw you false or null. This element is not common, but if you remember, you can do it in that way. Then we have some methods with the help of contains. So this contains work in the same way as it was working in your list, so there is nothing special about it. Then there are some other methods like your clear, which is again the same, it is going to clear your queue, again same. So let me just quickly execute. So you can see that since it was not containing Java, so this particular statement queue contains element Java is not printed. After clearing, it is size is 0. Other things, common methods are is empty, so that's again a common method here. So this one is same. And the next one is, can we add multiple items here also? Yes, it is possible to add. So first of all, you need to create a list, because there also in list, if you remember, we were doing it with the help of arrays.asList. So you can't say arrays.asQueue, that is not possible. So hence we are first converting it to a list, and then in the queue we are having the add-all method. And if you remember, add-all was taking a collection. So list is also a child of collection, so you can add it in this particular way. And the point is it going to contain the duplicates? So that also we will just see here quickly. So okay, let's wait for that one. It is going to contain the duplicates, but first let's just see this. So JavaScript, C# and Java is there now. Now let's talk about our final thing, that is sorting the queue. Now although there is no need to sort, because why do you want to sort a queue when it is already first in first out, but still if you wish, so this is the way. First of all, you need to convert your queue to a list, because your sorting can be done with the help of collections, and sorting was taking the list argument only. So first you convert it to a list like this way by saying new of array list queue. You can use linked list also, that's not an issue. Then we can print the contents, we can say collections dot, and this is going to import. So let's import it here, and then we can print the sorted list, guys. So here let me make it list 2, otherwise it will give me an error, or it will just print the empty, not an error basically. And let's see. So this is the way that you can sort your queue, but for this you need to first convert it to a list. Directly sorting a queue is not possible here. So this is with the queue. Now let's jump over to our deck part. So with the deck part, most of the things are again same. The only difference is this time here you need to write a deck. Implementing we are still doing with the linked list only. Then we will see the size is same, the way to print the size. The way to print the contents is also same. The way to add, that is also same, but not always. So when you will just say add, then it will always add at the tail. Let's quickly see. Let me just remove these and we will see now what it will do. So when I say something like this, it will add Java first, then Python, then C at the tail. Now you remember I told you about offer also. Let's repeat what we discussed in the add and offer. So I said that if there is a particular size restriction on your queue or deck, then add method will throw the error if you will overgo that particular size or beyond the size, but offer will just return you false, it will not throw the error. So that is the difference. And if you will just use them, they will always add at the tail like your queue. But there are some specific operations or some specific methods like add last here. So we have something like add last and offer last is also available here. Now what they will do, they will specifically add at the last only. So you will say that is same like the first one, but the only difference is the add method comes from the queue, hence it is available to Deque because Deque is a child of queue. Add last method is available only in the Deque. It is not available with the queue. The output will still remain same, that it is going to add the items at the end. And the interesting part is that Deque provides you some methods like add first or offer first also. And I hope it is just clear by the name. What they will do is they will add the items from the starting. So let's see. So it will behave something like this. So this time first we have added Angular. Now, so earlier Java was on the top. Now what we did was first we added Angular. So Angular got added on the starting, that is head. Then we added TypeScript. So TypeScript even came after the head of Angular. So it came like this. Then React and then Spring. So these are the different methods. Then we have few more common methods same as queue like element and peak. Let's repeat what we discussed earlier. So element can throw you the error if the item is not there. Peak will simply return you null if the item is not there, but they will not remove the items from your queue or Deque. Yeah. Let's see how to fetch the item in some different ways also. So here they give you something like get first and peak first. So there is nothing like element first. It's like get first. So get first and peak first are same as your element and peak by default. But there is some more different methods like your get last and peak last, which can return you the item from the tail, that is CSS here. Then let's go for a few more methods for removing. So here we have the same remove and the poll method available here, and you know they are going to remove from your head. So remove can throw you the exception, poll will give you null if the item is not there. Similarly, you have remove first and poll first also, which is same as your default remove and poll. So it's not much difference, same theory, but here we have something like remove last and poll last also available with us, which you can just quickly see here that remove last and poll last exist, which will remove from your tail. Rest theory is same sale. Remove last can throw you the exception, poll last can give you null if the Deque is empty. Other things like searching is always same, there is no difference in this particular part. So this you will see is exactly same. The clearing part is also same, there is no more difference in this particular part also, and the empty thing is also same. So all these are the common operations, so we won't spend time in learning them again. Then here also we have some more methods like add all, and as you know that add all is going to add the items, always add the tail. So this is there. Now do we have any method like add first all? That is something strange, but it is not possible. You only have add first. You can't say I want to add multiple items, add the first. That is not allowed. And last but not the least, about the sorting here guys. So sorting is the same here also. Let's just make some small changes. So we are doing it on the string. Let's call it as list 2, and this is your array list. Let's remove this, let's remove this, let's remove this too, and say Control Shift O. So for this sorting also you need to make usage of the list like you did for your queue. So Deque is almost same as your queue except some extra methods of removing or adding the items. Here you can add and remove items from both the ends. That's the only difference between these. Yeah. And let's move with our next demo. So in the next demo, what we have is here I have created a queue. Same again with the linked list. Now again on this you can iterate with the help of your enhanced loop also or iterator also. You cannot make usage of your index because directly accessing it with the help of index is not allowed. Iterator is still allowed because iterator will work with all the collections. Now what about Deque? So with the Deque, what happens is that again you can use it in the same way using enhanced for loop or using your iterators, and believe me, the output is also the same. But with Deque, there is one more thing which you will be getting, that is your descending iterator. So this is something extra which we will be getting now, a descending iterator, and it comes with Deque only. And this you can say this is same as your has previous which you were getting with the list. So it can move from your reverse direction, C, Python and Java. So this is the benefit. Another benefit is, in order to make usage of descending iterator, you don't need to bring your cursor to the end. Descending iterator always starts from the back only. So you don't need to first come to the back and then go. And here we don't go use the previous, we still be using next only. The only point is it is starting from the descending. Let's move further with our last but not the least demo. And in this demo it is nothing different, but we will just see how to remove integer since we did it for the list also. So just for the continuity purpose, so I have created a queue of integers and I'm removing queue. Now you saw that earlier when I was removing, I told you that we cannot remove any particular index, or since it is a queue we cannot remove anything in between. So how will this remove will work now? What will happen when I will say remove 1? So here this will take it as an object by default, not as an index. So this is something different. In list it was by default taking it as an index, and here it will by default take it as an object only, because in queue you don't have to do anything with your index. So when you will say remove 1, it's an object. Now it will see whether on the head do we have that particular object or not. If it is there, it is going to remove the item and will return you 2 and 3. But on the same thing, if you will just say 2, so now on your head you don't have 2. So now what will it will do? It will remove from the in between. So this is an extra thing which comes up. So if you will use the by default remove always from the head, but if you will give this, it will remove from the in between also. Yeah, but now on the basis of your object, not on the index. Now what if we write something like this, integer dot value of, this is also will be considered as an object only, nothing index here. So this will be the output as same only. So here the remove method always consider it as an object and never as a index, which is something to be remembered. And with this you can remove in between also, if you will use simple remove always from the starting. So that's it with the queue. Now let's start with the sets. So with the sets, again we will be quickly discussing the common methods, then we will iterate, remove the integer from set, then we are going to discuss the types of sets, then we will see how to create an unmodifiable set like we created the list, and then we will see how to sort the objects in set. Here you won't see like creating a set from the array, because again that is not possible. So let's see the sets in action in our demo 3. So we'll go here with our example 1. This time I have uncommented some of the things by default, and initially we will be saying set here, and here we will say hash set. Now as I told you earlier also, set is having 3 implementations: hash set, linked hash set and the tree set. First we will see the hash set, and then we will see the differences in our example 4. So this is your hash set. Again you don't need to give any size, and it is same like your queue or list, the same way to initialize. Then in order to check size, the common method coming from your collections. Then this is your content which it can print. Then in order to add, you can say add here, which is again the same way. So let's see how does it works. So this is the thing, guys. So initially the size was 0 and the contents was empty. Now size is 3 and contents is there. So this is the one. Now what you can't do here is that you can't say that I wish to add something at something index, because set means completely unordered structure. There is no index in your set. So all the operations which you were doing with the list using index, they are not allowed here. So you can't say add 2 comma SQL or something like this. Neither you can do the setting or any modification. You can remove the things in the same way like you were doing earlier also, but remember here the remove will always take object and never the index. So if the item is there, it will be removed. If item is not there, it will just simply return you false and not any kind of error. Then the searching is also the same like we did earlier. So this is your searching, guys. If it is there, it will show, otherwise not. Clearing is also same like earlier, and let's quickly see. Let's see the clearing part and the empty part, because again these are the common methods. I have just taken them in my code so that I can show you. Otherwise I don't think so we need to discuss about them explicitly, as we have already discussed in our list and queue in detail. So you can see on clearing it has made the size 0 and contents empty, and now it is saying set is empty. Search also works in the same way. Now what about, can we add multiple items to this particular set? The answer is yes, we can add multiple items also. So for this we will just see. And what do you think, will the items be added at the end or the starting? The answer is anywhere, because consider set as a kind of a bag where you are just putting the items. There is no index, there is no ordering, anything can go, anything can come from your set. So here we are adding the items. So what we are doing is, again you can't say arrays dot as set, that is not possible. So we are first taking it as a list, and then we will be using add all, because you remember add all can take a collection. So this way we will be doing here, guys, and this is our first set here. So let me first print this much only and see what do we got. So we got here C hash, Java and JavaScript, 3 items added. And difference you see, I added them in order like JavaScript, C hash and Java, but output is random because it's a set. There is no guarantee of order. Like, have you ever seen that there is a big bag and in that bag you are keeping some balls of different colors? Then I can pick any item out. There is no guarantee that this kind of color or that color will come out. It can be anything. So there is no guarantee of order on the output. Now I have one more set here, that is my list 2, and I will be adding this also. So what is the difference? Here we need to identify, will it add Java again? So here we need to identify, will it add Java again or not? Since it is a set, so the law says that set can only contain the unique elements. So whenever you just want a group of unique elements, always go for the set. What it will do is, it will say since Java is already there, I will ignore the next addition. It will simply skip it. It won't add it again or throw you any kind of error. So this is something to be taken care. And the last way, how to sort a set. So first of all, again there is no need to sort it, and hence you can't sort them directly like this. You need to take help of your list only. That's the only way. Let me make it for the string first so that it will stop giving us the error. And here I hope use the list and list 2 earlier, so let me call it as list 3. Now we can just sort our list 3 everywhere. So list 3, here also list 3, and here also list 3, and that is the way you can sort your set, but not directly, with the help of your list. And how you can convert? Just by saying new of array list set. You can call a linked list or array list, it doesn't even matters much as of now, but it will give you a sorted output now because that is the way. So these are the common methods, and you saw most of them things are there. The only things to remember that here they are not going to use index, so no method with index. Secondly, only unique methods are only unique methods can be there in your set. No duplicates are allowed. Let's go for the next and see what do we have there. So here we see the ways of iterating. Now here, since we don't have index, so I can't go for the simple for loop because it uses index, it's not there. So I'm only left with the enhanced for loop. So I have used it in the same way. Now there won't be any guarantee of order, so maybe I can get same Java Python C, maybe I can get some other order also here. Then I can make usage of iterator because iterator works with any kind of collection, so it is there. List iterator is not there, it is going to work with your list only. Descending iterator is not there, it is going to work with your deque only. And sets do not have any other extra or specific kind of iterator, so we just need to work with them only. And as you know, my favorite is enhanced for loop again. So these are the ones we have here, and you see the output is Java, C and Python, while I added as Java, Python and C. So it can be anything because it's a hash set, there is no ordering here. So let's close them. Next demo, guys. Now here we will be doing it for the integer, so it's same, just for the sake of continuity, like we did it for the list and queue also, so we are doing here. Now when I do the remove method here, so like you remember in the queue, the remove method was only taking your object. Here also, whether you say remove 1 or you say remove of integer value 1, it will always take your object only, and it will never take it as a index because index don't again exist here. So when we execute, the answer is same. So first time it removed, second time the item was not there, so it didn't even throw me any kind of error, and it just simply shown you 2, 3. So this one seems simple. Let's go for the next one. Now in our example 4, we will be discussing about different types of sets. So first one we have already discussed in detail, hash set, and this time what I have done is I have added multiple things. Java is good, you should learn this, and we will try to print the contents. Let's see what will it print. So I just wish to run this demo, so let me just run it from here, run as Java application. Not sure why is it confused so much. So it says Java learn should this good for you, something different it has printed. Java learn should this is good you. The reason is, whenever you are making usage of hash set, there is no guarantee on the order of output, and that is the way the set should work. So this is the fastest and the quickest one, which is the same, fastest and quickest, but fastest is more better. So this is the fastest one, guys. Then there is one more kind of set which we call as linked hash set. Let me just say Ctrl+Shift+2. Now all the methods are same as your hash set. The only difference is when you make usage of linked hash set, the output is same as input. So linked hash set is doing some extra computations, and it is going to remember, it is going to link them in the same order. Hence, whenever you are going to print or iterate over them, it will give you the same output. And the third one is your tree set, guys, which is again available here. The methods are same as always. There is no difference. The difference is still in the output, that this one will not give you the ordered by the way you added, but instead it will give you the natural ordering. Since all these are strings, it will consider them in the ASCII code. And in ASCII also, you know that the ASCII value of capital letters is smaller than the small letters. So first it is saying Java and U, both of them are starting capital letter, and then it is saying good G, then I, then L, then S, and then T. So the natural alphabetical order it has printed. Why J and Y came first? Because they are starting with the capital letters. Their ASCII value is less. So this is the major difference between your hash, linked hash, and tree set. So depending on your requirement, you can use them. If there is no specific requirement, my suggestion is always to go for the hash set, because this is the fastest. Here it doesn't need to do any kind of remember the order in which you added or do any kind of alphabetical order. So this is the quickest one possible. So we can go for it. Let's go for the next demo, and this time we will see the unmodifiable set. So like with the list, we have with the set also, that is set.off. So this is an unmodifiable, and it will also behave in the same way. I will just show one, rest I won't uncomment and show, but with this one I can show you that if you will try to add anything, it is not allowed. So neither you can add any element, neither you can remove any element, neither you can clear your set. Only you can instantiate them once, and then you can use them in whatever the way you wish to use. So this is your unmodifiable set available here. Yeah, and you can also see that internally it will be the hash set only, because there is no guarantee on the output, because that is the quickest one, as we remember. Now let's go for our final one, for the objects. So this time it is a set of employee. Again, Tom and Dick and Harry I have added in some random order I have done, and here this is my employee class. No comparator, nothing else. So if you have missed the comparator and comparable earlier, we will be discussing that again, but it's a same thing. So let's print this again and see what is the current output. So currently it is not showing me anything. Yeah, so why is it so? Why it is showing me some kind of error? So let's try to discuss. First of all, if you will use hash set, you cannot sort it directly. If you use linked hash set, again you can't sort it directly. The only sorting way is to go with the tree set, because we remember tree set will give you the sorting in the natural order, like it did with the string, it did with the integer. But how will it behave with the employees? Because it's an object. So this time when it wants to behave with the employees, then again you need to use the comparable here. It won't even ask you for using the any kind of sorting method, but you need to make usage of comparable, because it is inherently going to sort your set even without calling the sort explicitly. The only requirement is implement the comparable thing, and the same is the error, it cannot be cast to comparable. So what we will do is we will just say here implements comparable and employee here. So this we have done, implements comparable, and now let's quickly click here and let's see what is going to be the unimplemented methods. Let me remove it from here and add it here. So this is the one. So on what basis do we want to compare? That is again our choice. So let's use the same way. We will say o.id minus this dot id. What do you think what it will do? Ascending or descending order? We have already discussed this earlier. So the easiest way to remember is that just think whom you want to give the control. If you want to give the control to the outsider, they will do everything in the old reverse way. So if you will say o.id minus this dot id, and then you will just try to print here. See, I'm not even using collections.sort as of now. I'm just printing it out here. Let's see what it will do. So it will simply sort without any sorting method, because that is the job of your tree set, to give you the sorted natural output in the natural ordering way. And this video, if you want in the ascending order, always use this in the starting. This refers to the current object. O refers to the other one which is coming from the outside. So this is your output. So that is one. Now the thing is, what if we want to have some kind of custom comparison here? Then how to do? Let's say I want to do it on the name. So again, one option is you can go back here, you can change it on name, but then ID is not available. So I want name only sometimes. So then again, first of all, you need to create a comparator. So let's quickly create a comparator class. So we will call it as custom. I'm deliberately creating it from the scratch so that you understand. Otherwise, it is easier for me to copy paste the previous one also. So here we will say implements and we will say comparator, and we will again give employee here because we want to compare to employees, and it should be implements. That is the mistake I did. And now I will say add unimplemented methods, and here you can compare your employees. So if you will say o1 dot get name dot compare, because there is, okay, I have taken ID by mistake, let me take a name. So name dot compare, and here let's say o2 dot get name. Don't say name for one and ID for other, then you won't get any correct output, then it will be completely wrong. So if you will say o1 with o2, then again it is ascending. If you will say o2 dot and then o1, then it will be descending. But how to use it? How will this use here? Can I just simply say this and somehow it will automatically pick? The answer is obviously no. Directly, how will it come to know that it needs to pick that comparator? Now then, do we have anything like collections dot sort here? Let's check it out. So this is collections dot sort, and can we pass the set here? So this sort method takes only list, not a set. So how to do? The answer is, if you want to use a custom comparator, then you need to do something like this. Copy this, paste it here, create a new set, and when you create a new set, at that time only you put your custom comparator here in your arguments, custom employee comparator. Now to this new set, you can just say set to dot add all, and you can just say set. So all the items of the first set will come to your second set. That is possible, but you need to create a new set here in order to pass the comparator. No need of collections again this time. And since I'm doing it with set2, so it will look like this, and let's execute this. So this is your output. Second one is sorted by your name. First one by ID, second is by name. So here you don't need to use the sort method at all. Tree set is sorting them by default. If you will use the hash or linked hash set, then sorting is not possible. Only with the tree set it is possible. Hope this is clear. Now it's the time for our last but not the least, that is map. Now with the maps, you see here I'm having two things, k comma v, which means it is going to be a key value pair. It is just something like a dictionary in your Python, where you have a unique keys and values can be duplicate, but keys are always unique. So again, we will see the common methods, we will iterate over the method maps, then we will see the types of maps, and at the end we will just create an unmodifiable map. Here we are not going to work with the objects, because again that is not much difficult. If you have learned so much and seen so much, that you can try on your own also, and if you will face any difficulty, you can ask me. So let's go for our demo 4 here, and let's get started. So first of all, this time it is a map. So with map you always need a key and a value. Key can be anything, value can be anything. So just for our demo purpose, let's say the key is going to be an integer value is going to be a string here, and I'm creating a hash map for the first time. Now we will see the size or the length of map. So the length of map is always the number of keys, and you can use the size method, same like earlier. Then we can print them also, so same like earlier, nothing different. That's good. Now let's try to add the items. So for adding, since the map is not a child of your collection interface, you don't have an add method here. The method is put, and in the put method you need always two things. The first thing is a key and second is a value. Remember, this is not index, it is a key. Key can be anything. So on key 10 I'm having Java, key 2 I'm having Python, key 45 I'm having C. Why I have taken different numbers? So that you don't feel that these are the indexes. They can be anything in any order. So these are the things. Now let's see what will be the output here. So you can see initially the size was 0, map was empty, and this time we are getting this kind of braces. Then the size was 3, and here we are getting this as output. So this is your key equal to symbol, and then this is your value as Python, then Java, and then C. Again you will say that okay, why is it in the different order as compared to the input? Because we are making usage of the hash map. Hash map again gives you random output like your hash set. Theory is same like your set. Now let's move ahead and let's see how we can get a key, how we can get a value with like a key. So for this we will be using the get method, and we can pass on the key. So if I will say this, so it will say me Python. What if I say 20, the key which doesn't exist, error or null? So it will just say me null, not an error. So that is good here. We can add how to modify something. So for modify, we will just make usage of put method again. Now the same put method can be used for modification as well as for the addition. Now how is it possible? Because you know in map keys cannot be duplicated. So when you will do this, it will say that okay, 2 is already there. Then what should I do? Shall I ignore? Answer is no. It will just override the value to SQL. So earlier for key 2 we were having Python, but now onwards it will be SQL. So this is the thing. Then we can remove the things with the help of our keys. Again, if the key is there, it will remove. If the key is not there, it is not going to remove or throw you any kind of error. Then we can search it with the help of the key also. So we can say contains key. That's the difference. So we have a method here that is contains key, which will check on the keys. And similarly, we have a method here which we call as contains value, which will check for the values. So you can either check by key or by the value also. Both of them are possible. So if you say key, so let's say we were saying key 10. So for map contains key 10. So that was possible, and same with your value also it is there. What if a value is not there? So it won't show up. Now what if that two keys have same value? Then what will happen? Are we printing the key? The answer is no. From the value we can never get a key. We are just checking on the value. So it will just show whether it is there or not. Then we can do some common operations again, like clearing. So that is the same way. It will clear all your keys as well as values, and we can check whether it is empty or not. So that also can be checked out here. So these are possible things. Interesting. Just remember this important part, because this is the common mistake which people do. If you will put the same key again, it will replace the value instead of adding again or ignoring again. Then next, how to iterate over this. So this is again interesting. Now here we don't have anything like index. So indexed for loop will for sure not work. Now enhanced for loop can work, but This is something different. It's not that simple. So in order to make the enhanced for loop work, we need to take help of the set here. What we will do is, first of all, from the map, we will use a method key set. Again, how I came to know about all these methods? Just by practicing. So there are so many methods. As an individual, it's never possible to learn about all the methods in your career. So always learn about the basic methods, which we did in our example 1, and then learn about few more extra things like this. So you can make usage of your key set. What it will do is, it will return you a set of keys. Now what kind of set is it going to be? Obviously, if it is a hash map, it will be a hash set. Now it has provided us a set. So on this set, we can use the enhanced for loop, and then we can print key, and from the key you can always get your value. So this way it can be done, but directly no other way. Second way is that we can make usage of the entry set here. That is the other one. Now this entry set will give you a set of entries. That is a set of map itself, integer comma string, because our map was this. So this it will give. So here what this entry basically points is, from this entry you can get a key as well as a value directly, like this. So this is a little tough to understand, but this is the way it is going to work, directly an entry. This way you can assume that this is the way how the maps can directly interact with the help of your this enhanced for loop, directly working on the particular entry. A combination of key and value they call as entry. So what's an entry here? Combination of key and value. So this is the one. And the last one is with the help of values. So we saw only with the help of keys, then we saw the combination, and final is only with values. So with values you can do like this, values. Now values will not give you a set, because if they will give you a set, you will lose some of the values, they can be duplicate. So it will give you the collection parent, and on the collection parent you can use your enhanced for loop. Disadvantage for the last one is, you cannot get a key from this, because from the value you can never get a key. From key you can get a value, from entry you can get both. But if you are only interested in values, go for the last one. If you are interested in the complete entry, go for this. Otherwise, out of these, my favorite is key set, because it is simplest and easiest also to understand. Let's move on with the next demo here, guys. Demo number 3. So this demo 3 talks about the difference between the different kinds of maps. So first we have a hash map available with me, which I am printing here. So you can see this is pretty much simple, 30, 80, something and something I have printed. So it is just giving me the output, and the output is completely random. 80, then 17, then 34, 2, 56, 90 and 30. There is no logic for this, that on which basis it is doing. It's random overall. Now, one interesting thing when we always work with the map is, can map have a null key? Obviously null value is allowed, but what about a null key? Let's check here along with this when we were checking about various maps. So I'll make a null and I'll call it as A. So I will add a null key to a hash map and give the value as A, and let's print. So this is allowed, null, and again it is random, so anywhere it can be printed. Now I will put one more null. Now what will happen? If we will go by the simple rule, it should override the previous value and just give a single null key, and the value is B, because it has overridden. Let's see what it will do. So it will do in the same way. It will just give you one null and override the value as B. It will not give you two nulls. So hash map is simple. It can contain the null keys, but only one null key. If you will add more null keys, it will keep on overriding values. Next is linked hash map. And as you remember from your linked hash set, it will remember the order in which you are going to add the items. So for this also, let's check about null things. So we will see. Now here we will see that it has remembered the things. So first is 30, then 80, then we will see 17, then we have 56, then we have 34, then we have 90, then we have 2, and at the end we have null. And null, second time it has overridden. So this is the one. Hash, linked hash, both can contain null. The only difference is linked hash will remember the order of keys, not values. Or you can say it is same. If it will remember order of keys, it will be values also. Yeah. Last is the tree map, the natural ordering things. So let's do this. First without null. So if we execute, so you can see it is the natural ordering of your keys, not the values, because T, S, T, so it is not values, it is about natural ordering of your keys. So that one is clear. Now what about null? Will it allow null or not? Let's see with one null. So there is no error, and on executing it gives you an error. So tree map will never allow a null key. The reason is because on its implementation, because you know in tree map what it needs to do, it needs to sort them in the natural ordering. Now remember, all these are integers, so when it is sorting internally it must be using some kind of that comparable interface. If it is using that comparable interface, it is comparing two numbers, two integers here, and whenever it will call the method compare on your null, it will give a null pointer exception. So with tree map you cannot even have a single null key, so this one is not allowed. So we need to remember this, and that's the only difference between your various maps. And if there is nothing, so my favorite is hash map. Let's go for the last but not the least, and that is unmodifiable map. So this unmodifiable map works like this: map.off, and then just simply start giving your keys and values. Just remember that first key, value, then key, then value, and this is the way so to do. And as always, since it's an unmodifiable map, I don't need to explain them one by one, but we can just remember that since it is an unmodifiable map, neither you can add a new element, neither you can modify, neither you can remove, nor you can clear them. Yeah, so these are the things, and yeah, I don't think so then there is anything to be executed here. So this will be the kind of your output, and it can be any order, so it will be must be using some kind of hash map internally. Yeah. So yeah guys, that's it with the collections framework. So here I think it's a very long video, one of the longest video which we have created till now, but we discussed everything. First we discussed the drawbacks of array, then we discussed about various kinds of collections, then we went for the difference between the collections and collection, then we discussed about the things like list, set, maps, as well as the queue. We discussed about the comparator and comparable interface. We discussed about the iterator also, and all the implementations. So hope you have liked, and very soon we will be creating a video on streams, for which obviously this is going to be the prerequisite. So hope you have liked, and since it's a very big video, so much time has been consumed here, please at least give a like if you even like the part of it, and just comment something so that it gives an energy to me for the next one. Thanks everyone.